Silicon photonics will be critical to enable new network architectures with increased bandwidth density and reduced power. Addressing this issue in the ECOC market focus, as well as trends across the industry, has been Robert Blum of Intel, and he joins me now. Robert, tell me why silicon photonics is so important.
Well, obviously silicon photonics provides really scale and volume manufacturing to the optics industry, right? And if you look at data centers today, data centers are front and center to everything we do. And we talked about these 100 gig connectivities in the data center, right? So to interconnect all the switches in the data center, you need high-speed 100 gig optics. And that's been really an issue for suppliers to scale and provide that connectivity, in high volume at the right cost points for those data centers, right? And so we talked today about, last year we announced that we're in volume production, but that was one part number. It was a PSM4 transceiver, and now we're actually in volume production on the CWDM4 part. And that has a whole big application, not just for data centers, but also for enterprise applications. And we can cover reaches from 500 meters all the way to 10 kilometers. So in essence, silicon photonics really gives you fundamentally different cost structures compared to traditional optics. Gives you the ability to scale in high volume and really enable data centers to grow to the next level.
And talking about the next level, what comes after 100 gig?
100 gig is being deployed today and still ramping, right? But after that, we really see 400 gig, and there's actually quite some activity around 400 gig. And in fact, at the show, we just announced the formation of a new multi-source agreement to define 400 gig over duplex fiber, CWM8 MSA, that really defines link budgets for 2 kilometers and 10 kilometer reaches to enable these next generation high-speed links. Because yes, you're deploying 100 gig, but people are already expecting next generation switches with 50 gig SerDes early next year, early 2018, and for that you need 400 gig. So we're really trying to accelerate the deployment of 400 gig optics and really enable data centers to deploy high-speed connectivity in volume and at scale.
And dare I ask it, what about after 400?
And we talked about it in the talk a little bit as well, right? I mean, at 400 gig you have these pluggable interfaces that are getting deployed in those switches. So you have QSFP double density or OSFP form factors, or you could go onboard optics. But beyond that, so they're good for 12.8 terabit of switch capacity. But beyond that, really, it becomes harder and harder to do things the traditional way, to use pluggable optics. And so we really see the integration of optics with networking silicon as you go to switch densities of 25 terabits or higher, right? So it's really silicon photonics that enables that type of integration, where you can have the optics really tightly coupled to your silicon, say in multi-chip packages, very closely to each other. And that really gives you much improved power dissipation, improved performance in terms of your overall performance, but also in terms of your link between the optics and the electronics, and really drives fundamentally different network architectures. Once you have a solution like that, you can really re-architect your data center. You can move away from these traditional top-of-rack switches, drive optics to the server, and that's really what we talked about in the talk today.
Okay, well, thank you very much for joining us.
Thanks, Brian. It was a pleasure.